Hi everyone. Today I'm going to be going over dimensional analysis practice number 3. If you were confused about any of the questions, make sure that you have a little look at this video. You can fast forward to the question. You can play it at 1.5 speed, whatever works best for you. But remember, you're going to be having an application tomorrow, which is graded for accuracy. All right, you have the equalities at the top of the page. You will always get those equalities. You will have them available tomorrow. You can use the paper version of the equality sheet, or you can just use the equalities that will be embedded in the Google form. So let's get started. The first question says that an athlete drinks around 0.7 gallons of water every day. How many liters is this equal to? Starting with 0.7 gallons, going to liters. I have an equality between gallons and liters. So I start with 0.7 gallons over 1, set up my fraction, my conversion factor. I'm going to have 0.264 gallons in the bottom. Remember, I found that in my equality. 1 liter up top. My gallons cancel. I divide, and I get 2.65 liters. Number 2, the Falcon Heavy spacecraft, it's a real thing, weighs 1.42 times 10 to the 6 kilograms. Convert the weight to pounds. I have an equality between kilograms and pounds, so that means I'm only going to have one conversion factor. 1.42 times 10 to the 6 kg over 1. Remember, we like to put it over 1 as a placeholder. Since I already have a conversion factor, I'm only going to need one fraction. 2.2 pounds will go in the top, 1 kilogram in the bottom. Remember, we want to diagonal cancel, so we put the kilograms on the bottom. Multiply across the top, we find the mass is 3.12 times 10 to the 6th pounds. Remember, when you're putting scientific notation in your calculator, you replace the times 10 with the E button, and you always want to go to 2 decimal places when you're putting your final answer. It takes Uranus 84 Earth years to revolve around the sun. How many Earth hours does this journey take? We mentioned Earth years and Earth hours because the definition of a year is different than the definition of an hour, and the numbers are different on different planets because it takes a different amount of time to revolve and rotate in science. All right, so I'm trying to get from years to hours. I don't have an equality, so I need to use 2 fractions. So I start with 84 years over 1. I want to get rid of years, so that means I must have it in the bottom. 1 year, and it's equal to 365.25 days. My years cancel. I have days, but I'm trying to get to hours, so I need another fraction, another conversion factor. I know that 1 day is equal to 24 hours. My days cancel, and I simply multiply across the top and find that it takes 736,344 hours. Venus's average distance from the sun is 1.08 times 10 to the 8 kilometers. We want to see that in light years. Now remember, light years is a really, really large unit of measurement, so this should be a smaller number. I do have a relationship between kilometers and light years. So I'm only going to need one fraction, one conversion factor. I want kilograms to be in the bottom. Kilometers to be in the bottom. Using my equality, 9.46 times 10 to the 12 km. 1 light year up top. Kilometers cancel. Now we have division. It is 1.14 times 10 to the negative 5 light years. Just kind of shows how large of a unit of measurement light years is. Sorry, that light year looks a little funky. 5 light years. Close enough. All right. Neptune has a diameter of 4.86 times 10 to the 4 kilometers. We want to express this in miles. Now, we do have a relationship between kilometers and miles, so I'm only going to need one conversion factor. 10 to the 4th km over 1 is my placeholder. I only need one conversion factor. I know that 1.609 kilometers is equal to 1 mile. So 1.609 km in the bottom, 1 mile up top. Be careful. When you're writing mile, you might want to write MI or MIL. If you just put M, you may get confused and think that's meters. Very different units of measurement. Division, so 30,205.10 miles. All right. Question number 6. By the time you finish reading this question, the Earth will have traveled 312 kilometers. How many centimeters has Earth traveled? Well, I'm starting with 312, trying to get 2 centimeters. I don't have a relationship between kilometers and centimeters, so I'm going to have to use 2 fractions. 312 kilometers over 1. Let's set up our first fraction. We know that 1,000 meters is equal to 1 kilometer. My kilometers diagonal cancel. My next fraction will allow me to go from meters to centimeters. We know 1 meter is equal to 100 centimeters. Diagonal cancel. Then we're going to multiply across the top. And we should get 3.12 times 10 to the 7th centimeters. I put it in scientific notation because that's pretty large. All right, number 7 is a little bit of a challenge. It takes some thinking. You can't just simply start based on the numbers and units that you initially see. So the question is, Mercury has an orbital speed of 47.8 kilometers per second. How far will Mercury travel in 47 minutes? So the second part of the question is really what we're going to be starting with. So I'm starting with 47 minutes. I want to know how far it is going to travel. And the distance I'm going to want is kilometers. How do you know it's kilometers, Mrs. Fox? Well, based on this fraction here, the 47.8 kilometers per second, I can see the unit is kilometers for the distance. I need to get rid of seconds. Well, I need to get rid of those minutes and I need to get rid of those seconds. So let's just start to set it up and talk it through. So I'm starting with 47 minutes. I'm going to put that over 1 for our placeholder. Now, I want to know how far it goes, but 47 minutes isn't really going to help me yet because I won't be able to get rid of the seconds. So I need to get rid of my minutes and convert those. So 47 minutes, we know, is the 60 seconds. Sorry about that. 60 seconds over 1 minute. My minutes cancel. I needed to get rid of those minutes and get to seconds because that is what my fraction within the question says, 47.8 kilometers per second. Now, I'm going to use that ratio. I want to get rid of seconds, so I'll put 1 second in the bottom, 47.8 kilometers up top. Remember, this number right here could also be written as 47.8 kilometers over 1 second. That's what per second means. It's the bottom of the fraction. My seconds cancel. So now I simply multiply across the top. And I can see that after 47 minutes, Mercury will have traveled 134,796 kilometers. This is definitely more of a challenge question, so don't super freak out. We want to know which is shorter, 26.4 centimeters or 12.3 inches. The only way that we can compare these two numbers is if we have them in the same unit of measurement in order to compare. I'm going to change the 26.4 centimeters because that's just the first one in the problem. So 26.4 centimeters. I have to get it into inches in order to compare my two numbers. And I do have a relationship between centimeters and inches. It's 1 inch is equal to 2.45 centimeters. My centimeters cancel. So now I have a division problem. 10.39 inches. So now that I have the numbers in the same unit of measurement, I can compare. I'm asking which is shorter. Well, 10.39 inches is shorter, but that's not the answer. The answer is 26.4 centimeters is shorter. All right, hope that helps. If you have any questions, please reach out to your teacher. I'm more than happy to help. Have a great day, everyone.